What is up, everybody? Welcome to the first part of the review, and this is the first part of the review, and the reason why I make it the first part of the review is because it's going to cover the first 4 sections right here that I have, but it's basically just the first 3 sections of the book, the 4.1 to 4.3, and the reason is the chapter has been split for the Precalculus in my school. That's happening right now. So there's 2 parts of the chapter. There's 4A and 4B, and this is 4A. So this is 4.1 through 4.3. We're going to be covering this 4.4 to 4.6. I've significantly lowered the number of no, not 4.6, 4.8. I've significantly lowered the number of questions, so it shouldn't be too scary as of right now. So let's get started. The DMS. What is DMS? It's degrees, minutes, seconds. So it's like hours, but instead of hours, minutes, seconds, it's degrees, minutes, seconds, and degrees don't go to 24; they go to 360. So the fractions are the exact same, right? Hours, minutes, seconds, 60 minutes in a second, 60 minutes in a degree, and 60 seconds in a minute, right? So if you can look at this right now. So if you take this 0.758, this remainder of the fraction, and you multiply it by 60, you'll get this. And then you take this, you multiply by 60, you'll get the number of minutes, and then you take the remainder of that, you multiply by 60, and you'll get the number of seconds. In this example, convert 123 degrees, 12 minutes, and 26 seconds into degrees. You multiply this by 1 over 60, because that's the number of seconds, minutes in a degree, 60, and 3,600, because that's the number of seconds in a degree, or seconds in an hour. Oh, sorry. So that's how it works. So we're going to convert this 0.283 degrees into the degree, minute, seconds. So first of all, we know we have 0 degrees, right? Okay, I need to change to blank. 0 degrees plus 0.283. We're going to take this, multiply by 60, so that'll give you 1,680. So 283 times 60 is, I'm sorry, I'm bad at math, 188. So 1898, 18980. And since it's 0.283, it'll be 18.98 minutes. Right, 18 minutes and 98.98. So you take the 98 now, and then you multiply that by 60, and then what you'll get is 5,880, I think, if I did the math right, and that'll be 58.8. Right, this is 0.98, 58.8. So your final degree, minute, second notation will be 280. No, 283 isn't part of it. So you'll have 18 minutes, 0 degrees, 18 minutes, and 58.8 seconds. Next, 92 degrees, 3 minutes and 45 seconds into degrees. So what you do is you take the 92 degrees, and it's already degrees, so you don't really need to worry about it. How many minutes in a degree? Well, 60 minutes. So you multiply, you add by 3 over 60, and then how many seconds? It's 45 seconds in a 3,600 seconds in a degree. We have 45 of those seconds. So 3 over 60 is 1 over 20, and then 45 over 3,600 is 5 over 400, which is, in decimal, that's 0.05. And in decimal, this is 1 over 80, so 0.0125. So this will be 92.0625. If I ever calculate any of these wrong, please tell me in the comments, because I don't really bother to check them. because I calculate stuff in my head. I want this review to go fast, so there you go. It's only been 5 minutes. We already go through 3 pages. Okay, that's good. A bearing is the angle of the line of travel, or vector, right? So I should put arrows here. A vector, do a line usually north from the clockwise direction. Did I kind of confused you right there? But a bearing is just when something's pointing up. The bearing is the angle that it produces until it hits the next one in a clockwise direction. So for this one, 140 degrees, this is not the bearing of the vector. This is the bearing of the vector right here. This is the bearing. See? This is the bearing because it's going from the north clockwise. So 140 isn't the bearing. 140 subtract from 360, which is 220. That's the bearing. How about this? Bearing from P to Q, that's P. Right? That doesn't matter where north is. Even if north is right here, it doesn't matter. Because we want the bearing from P to Q. We don't want the bearing from north to Q and north to P. If we took the bearing from north to Q, then we already know that it's going to be whatever it is. And I didn't even put an angle. Let's just put just theta. Let's put theta. Theta is a Greek symbol, meaning angle. Right? It's used to signify angle, so it's not x, it's theta, right? So if we do the bearing, which is this direction, remember, because it's a clockwise, it'll be 360 minus theta, and if we do the bearing from Q to P, it'll be just theta, right? So this is theta, and this is 360 minus theta. So we're gonna go on to an even more important. We have an even more important concept now. So the other concepts, the radians, angles, degrees, they're important, but they're not too the bearing, angles, and degrees. Yeah, they're not too important. This one's what we want. This one's what we want to focus on. It's the radian. Now the radian is you guys already know what the radian is. Probably from earlier classes like geometry or integrated math too, but I'm just gonna review it. And the radian is the measure of the radius, the measure of the angle where the circumference is the same as the radius. So if I could go through this derivation process, c over k is 2 pi r, right? K is what k is what we want to find when we find the increment that 1 radian covers for the whole circle. So 1 over 2 pi is what you get for k. We go through this. We have r is equal to c over 2 pi k, right? If r equals 1 and c equals 1, which is what we're looking for, right? R equals 1 and c equals 1. Then you have 1 equal 1 2 pi k. So k is equal to 2 pi. No, wait, no, k is equal to 1 over 2 pi. Yeah, so once we take this 1 over 2 pi, we have 1 over 2 pi, and we have 360 degrees. 360 degrees in one circle. So we take this 1 over 2 pi, part of the circle, and we multiply all by the 360 degrees, we'll get 360 over 2 pi, which simplifies to 180 over pi. So this is the definition for radians, about 180 over pi, or 57 degrees, roughly 57 degrees. But it doesn't matter if it's 57 or not, because these are the conversion rates that you need to know, right? If the radius and the circumference is 1, we can solve for k, which gives you the part of the circle that 1 radian belongs to, multiply by 360, and that's how you get the amount of the number of degrees in a radian. These are the conversions. You should remember them. 1 radian is 180 over pi. 1 degree is pi over 180. I forgot to put that. So 1 degree is pi over 180. No, wait. Yeah. 1 degree is pi over 180 radians. 1 radian 180 over pi, 1 degree pi over 180. So from this definition, the circumference of the sector is the radius multiplied by the number of radians, right? Because if we have this is 1 radian, right? This right here is 1 radian. If we have a 2 radian picture, so this is 2 rad. Rad is the shortcut for radian. If we have 2 radians, that's r. So this has to be 2r. That makes the most sense, right? 3 radian, 3r. 4 radian, 4r. So find the circumference of a 120 degree sector with radius 1. This is 120 degrees, not radians. So we're gonna have to use our conversions. So 120 times pi over 180 is equal to, because 1 degree is 1, so 120 is 1 degree pi over 180. 120 is 120 times pi over 180, which is 120 pi over 180, or simply 2 pi over 3. And that's it. That's the number of radians. Radius is 1, so that's the circumference. It's 2 pi over 3 radians, which is about, I say, 2.09. It's only 2.09. Right? So next is find the circumference of a 1 radian sector with radius 3. This time the radians is only 1 and the radius is 3. Circumference is radian times radius, so it's 3. Find the central angle of a circle with the radius of 8 and circumference of 12 pi. This time it's a little bit more complicated, with circumference is equal to theta times radius. And we already know that our circumference is 12 pi, and our radius is just 8. So 8 theta is equal to 12 pi. So theta is equal to 12 pi over 8, or 3 pi over 2, which is 135 degrees if you really wanted to know. But you can leave it. You should be able to leave it at 3 pi over 2, and it should be nice, right? Next, page 5. The area of the circle is pi r squared. Now, this probably won't be emphasized. It might be emphasized in the test, but it might not. But the area of the circle is pi r squared. So if we want to manipulate, manipulate this, we can find the area of a sector instead. So we have pi r squared, and then we all know that theta and 1 over 2 pi. So there's 2 pi radians in a circle. So we have to divide it by 1 over 2 pi if we want theta to be 1 radian. So we divide the whole thing by 2 pi, and then we multiply by radian. So radian over 2 pi, basically. Because if it's the whole thing, then theta would just be 2 pi. 2 pi over 2 pi, that's 1, right? So that's 1/2 r squared theta. 1/2 r squared theta is the formula, and we want to find the area of a circle with a sector of 105 degrees. Once again, it's degrees, so we have to convert it to radians. Let's do that right now. 105 times pi over 180 is equal to 105 over 7 pi over 12. And a 150 degree sector. Okay, this is I made this really hard for no reason. So this is our sector. This is our sector, right? So we want to find the radius first, because we have our circumference and we have our 100. We have our degrees and we have our circumference, but we don't have our we don't have our radius, so we have to actually find it out. And if the 150 degree sector circumference is 5 over pi, right? But we only want 105 degrees, so we're gonna find a radius first, and then we're gonna multiply to put it in this formula, right? So 150 degree sector circumference of 5 over pi. So 150 degrees multiplied by pi over 180 is 5 pi over 6. And then if you take the 5 pi over 6, and that's equal to that multiplied by the radius is equal to 5 over pi. Right, this multiplied by the radius is 5 over pi. So if you multiply by 6 over 5 pi on both sides, multiply by 6 over 5 pi, we have a pretty nasty canceling. So you erase 5 on both sides, you'll have 6 over pi squared, and that's your radius right there, 6 over pi squared. So if you take the 6 over pi squared now as the radius, you can put it back in. Oh my god, I need to make more space for myself. Let me move this up a little bit, and let me move all of this up a little bit as well. 6 over pi squared, 1/2 times 6 over pi squared times 7 pi over 12. And if you put this all in a calculator, you'll get 1/2 36 over pi, so 1/2 times 36 over pi to the 4th power times 7 pi over 12. 2 goes into 36 18 times. I'm just going to calculate this and not waste time. It's 21 over pi to the 3rd power, and that's your answer right there. So I'm sorry for having such a hard example. I should put an easier example next time, but we can move on to this question. These questions, I should say. Question 42 for 4.1. So the question 42 for 4.1 says, which compass direction is closest to the bearing 219? If you look at the compass, you'll see this, right? The north, east, south, west, northeast, southeast, southwest, northwest, right? North is 0. We have east as 90, 180, 270, and then 0 again, right? Because 0 is north, and then we go clockwise. So what's to the closest direction of 219? We have 219. Actually, I'm gonna remove this question right here. This question's a pain. So 219. If you take this 219, which one is it closer to? Is it closer to 180, or is it closer to 270, or is it closer to this middle compass right here that we have? What is this middle compass? It's the average of the two, right? So 180 plus 270 over 2, or just the middle, which is 225. So 219 is really close to 225. So the answer is actually southwest, because it's the closest to the southwest compass direction. It's closer to southwest than it is to west-southwest, or south-southwest, which is one of the directions in the compass as well, in the book, right? So if you look at the book, I'm going to refer to many things that are going to be in the book, that won't be not in the book. What am I saying? It's going to be in the book, so you better know it, right? So next is tool design. A radial arm saw has a circular cutting blade with a diameter of 10 inches. So this, we have a saw with like a spikes on it. I don't know, it looks like a sun. And it has a diameter of 10, and it spins at 2,000 rotations a minute. So if there are 12 cutting teeth per inch, 12 teeth per inch on the cutting blade, how many teeth cross the surface per second? So we have 10, and our circle radius is 2 pi r, but this is also the same thing as pi times the diameter, pi d, right? So we already have our diameter is 10, so it's just 10 pi. It's just going to be 10 pi. That's our circumference. So our circumference 10 pi, but there are 12 cutting teeth per inch on the cutting blade every single second. No, every single inch. So 10 pi, we can multiply that by 12, 120 pi. Now we have 120 pi teeth that are going through every single revolution, every single time it rotates. It rotates at 2,000 rotations a minute, but we want the rotations a second, so we're going to multiply by 2,000, but divide by 60, because we want the rotations a second. So if you multiply this by 2,000, divide by 60, you can cross these two off. We have 2, and then this is just gone, but we're going to put a 1 anyways, and then that's 4,000 pi teeth. 4,000 pi teeth, which is around, what, 3.141, so that's 12.56, 12,564 566 teeth, because it's 3.1415. So there you go. 4,566 teeth across the surface every single day, not day, second. It spins at 2,000 rotations per minute. That's pretty impressive. I'm gonna be really honest. Okay, next we have trigonometric functions. This is lasting longer than I thought. Trigonometric functions are functions to describe a triangle, and the relationships between the angles and the sides of a triangle. So there are other trigonometric functions that are reciprocal of the actual trigonometric functions that we have. For example, sine is, we can follow this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA, right? Other trig function, and these are the other trig functions. So the cosecant is a reciprocal of the sine, secant reciprocal of cosine, and cotangent is reciprocal of the tangent. It's 1 over, right? If you see this sine and cosecant, sine and cosecant, see, every single time that you go through, there will be a co next to it. So sine is cosecant, the opposite of cosecant. Cosine is the opposite of secant, right? There's no co. And tangent is the opposite of cotangent. So co, and co. There's always a co, right? If one isn't a co, the other will be a co, right? It's a little that sounds so weird. So let's compare the sine of sine CSC and tan of theta 1 to the cosine, sec, and cot of theta 2. I'll make it easier. I'll make this easier. 6, 10. And this will be 8. So this will be 8 because of the Pythagorean theorem. And we gotta make sure this is a right angle triangle. It only works for right angle triangles. So sine of theta 1 is opposite over hypotenuse, 6 over 10. Sine is 6 over 10, which is 3 over 5. CSC is cosecant. Cosecant is 1 over cosine. So the cosine is 8 over 10. The cosine of theta 1 is 8 over 10. So the cosecant is 10 over 8, which is 5 over 4. And then the tan is opposite over hypotenuse. Opposite over hypotenuse is 6 over 8. No, opposite over adjacent, I mean, which is 3 over 4. Right? Now let's see about cos of the theta 2. Cos of theta 2 is theta 2 we have right here, 6 over 10. It's also 6 over 10. It's the same as sine of theta 1. Cos of theta 2 is the same as sine of theta 1. Okay, let's see if it holds for all of these. Secant of theta 2 is 1 over cosine. What's the cosine? The cosine is secant is 1 over the cosine. So the cosine is 3 over 5. Actually, where the cosecant is, I am sorry, I made a mistake. The cosecant is 1 over sine. Cosecant is 1 over sine, but it's CSC. That's the abbreviation, which is 5 over 3. And then this is 5 over 3 as well, because it's 1 over the cosine of theta 2. Tangent, cotangent is cot. So cotangent is not opposite over adjacent, adjacent over opposite. Adjacent over opposite is 6 over 8, and that's 3 over 4. So why did this come out to be the way that it works? Because we have sine, we have cosine, complement to the sine, complementary sine, cosecant and secant. So cosecant is the complementary to the secant. So if you take the cosecant of the opposite angle from the right angle triangle, you will get the same measure. Tangent, complementary tangent. Complementary tangent, if you take the complementary tangent of the other angle, you'll get the same result as if you take the tangent of that angle. So that's what complementary means. That's basically what complementary means. So we have our special right triangles right here. What's our special right triangle? And can you guess the degree of these measures of these triangles? Well, first of all, we'll work out the sine, cosine, tangent first. So this is theta 1, and this is theta 2. So let's do theta 1 first, right? Theta 1, sine, opposite over hypotenuse, square root of 3 over 2. Cosine, adjacent over hypotenuse, 1 over 2. And tangent, opposite over adjacent, square root of 3. What about theta 2? This is theta 1, and this is theta 2. Sine, cosine, tangent. So theta 2 sine is 1 over 2. Theta 2 cosine, square root of 3 over 2. See, you see the pattern? Tangent, 1 over square root of 3, or square root of 3 over 3. Right, 1 over square root of 3. I'm gonna leave it like that. So you can see that the sine and the cosine of the complementaries are equal to each other. The cosine and the sine of the complementaries are equal to each other. See? Okay, this is sine. This is pretty obvious, right? The degree of this is pretty obvious. It's a right triangle and it's isosceles. So this is automatically 45, and this is automatically 45. Right? So the sine of 45 degrees. The sine of 45 degrees is opposite over hypotenuse, opposite over 1 over square root of 2. Or I actually like square root of 2 over 2 more, because I'm going to tell you why. This is 1 over square root of 2 as well, because it's adjacent. Adjacent is the exact same as opposite. In this case, tangent of 45 is 1 over 1, which is just 1. So, what is the degree measure of 1 and 2? Well, if you think about it, that's 2, this is 1. If we make another triangle, okay, sorry for the scuffiness of that. If we make another triangle with 1 and 2 again, what does this become? It becomes a 2, 2, 2 triangle. It becomes equilateral. Equilateral triangles means that this is 60, so theta 1 is 60, which makes theta 2 automatically 180 minus 60 minus 30, which is 180 minus 60 minus 90, which is 30 degrees. So this is 30 and this is 60, and this is 45. So theta 1 is 60. I'm gonna write over it 60 degrees, and this is 30 degrees. Next. Okay, this is common calculator mistakes whenever we're computing trig functions, right? Common calculator mistakes. You can look through these and tell me if anything is confusing. But we're gonna solve these triangles for A and B. We're gonna solve these triangles right now for A and B. So 9. This is 9. What's A? What's B? So we have 41 right here. We can do sine of 41 is equal to 9 over b, right? Just like normal. And we can use our equation solving skills to do b is equal to 9 over sine of 41, which I don't know what the answer is, but if you can calculate this, if you can put these answers down in the comments, I'll heart your comment. Pretty simple way for me to not do any work. And then since we have this already, we can do the Pythagorean theorem, but obviously I'm just going to do the trig functions because they take less time. So we have a tan of 41 now, because we're dealing with this and this, and we want to find A, is equal to 9 over A. So A is just 9 over tan 41. And those are the two answers. Make sure you convert it into the radians, right? And make sure you convert it into the degrees. I mean, this is degrees, 10 degrees, right? This is the common mistake. If you do 10 radians, you're wrong. You have to put in 10 degrees. If you put it 10 radians in Google, sine of 10 in Google, it'll default to radians. So make sure you put in degrees, right? I'm pretty strict about that. So this is 5, this is 10, and this is B. The relationship might seem a little bit hard to find at first. If you can find it, pause the video, please now. Pause the video. I'll reveal the answer in 3, 2, 1. Okay, so 10 is 2 times 5. 10 is 2, 10 is double 5. So what is this? If it's a right triangle, if we go back here, 1, no, 1 square root of 3, 2. 2 times 1. See, 2 is 2 times 1. 10 is 2 times 5. We have square root of 3 down here, so it will just be 5 times square root of 3. It'll be the same thing, but 5 times it. Right? Which automatically makes this, since this looks bigger than the other angle, right? This is automatically 60, and that's automatically 30. So A is 60, and B is 5 square root of 3. Done. Okay, is this the time? Yep, okay, I have to sing now. I'm sorry. Okay, so credits to Mathematica Paulo 1419 for prepping his GCSE students with this song. But this is a simple way to remember the 30, 45, and 60 for sine, cosine, and tangent. And it goes, okay, I really don't want to sing. It goes 1, 2, 3, 3, 2, 1, 2, under everybody. Square root, where it has no 1, so there's no 1 in these two. Square root of 3 over 3. 1 square root of 3. Now that I've learned, I will sing to you, see. Okay, so we'll do it again. 1, 2, 3, 3, 2, 1, 2, under everybody. Square root, where it has no 1. Square root of 3 over 3. 1 square root of 3. Now that I've learned, I will sing till you see. Okay, I just wasted so much time right there. Anyways, that's how you remember the table. I'm gonna put the video in the description for this. This is so genius. Right? So 1, 2, 3, 3, 2, 1. If you want to find what tan of 45, square root of 3 over 3, 1. 1 is where it stops. So you automatically know it's 1, right? Or cosine of 60. 1, 2, 3, 3, 2, 1, 1, 1, and then 2 under everybody. So it's 1/2 automatically, right? Because where has no 1? There's no 1 in cosine of, there's a 1 in 60, so there's no square root. There you go. So tan is yeah, this is just a way to you know, I'm not gonna do this question. This is just a way to find the trig functions of pi over 6, pi over 4, pi over 3, 30, 45, 60 easily, right? To remember them. There's another way. I will tell you later. So tan theta is 3 over 4. Find the other 5 trig function values. Let's see. That's theta. Tan theta is 3 over 4. So opposite over adjacent. Opposite over adjacent is 3 over 4. Opposite is 3, and adjacent is 4. So what's this? What's the angle of this? 3, 4. So this, okay, this is just really bad triangle, I'm sorry. So it will be 3, 4. 3 squared plus 4 squared is c squared. I'll write that down. I really don't want to write that down, but I'll write that down. So c is 5. Find the other 5 trig. So first of all, we have sine. What's sine equal? Sine, cosine. Sine is equal to 3 over 5. Cosine is equal to 4 over 5. Cosecant is equal to 5 over 3. Okay, I'm sorry about that interruption. So cosecant is 5 over 3. Secant is 5 over 4. Okay, I'm really sorry about the bad handwriting as well. So cotangent is reciprocal of tangent, so it's 4 over 3. Right now we're gonna try to go to the 2.2, question 62. So we have this height question where Kirsten places our surveyor's telescope on the top of a tripod 5 meters above the ground. So we have this tripod right here, and it captures a tree, right? It only captures part of the tree because there's another part that isn't captured and it's 5 feet long, and it's 8 degrees of 120. Right, so this is assuming this is the right triangle. What's the height of the tree? So let's say this part of the height is h. So 8 degrees and 120. So we have this h, we have an opposite, and we have the adjacent. So tan 8 is equal to h over 120. So h is equal to 120 tan 8. And then the whole thing is 120 tan 8 plus 5. So the answer is 120 tan 8 degrees plus 5. And that's, I think I worked in my book. I think it's about 11 feet. Right? It's question 62. So it will be, it's about 16.8. 16.865 feet. Question, next, number 10. So this is the start of point 3. This is the start of 10.3, not 10.3. Point 3, right? This is the start of point 3. 4.3. There you go. My head was blank. And we have some terminology to discuss. The measure of an angle. I'm gonna discuss all the terminology right now. The measure of an angle is the number that describes the rotation from the initial side to the terminal side. So if you have one right here, if you have one right here, and then you have one right here, the initial side is always the side on the right of the terminal side. Initial side's always on the right of the terminal side. So if it's like this, the initial side's on the right here, even though it looks like it's on the left, it's on the right. So whatever comes first whenever you go counterclockwise is the initial side, right? And this only applies for this situation that we're in right now. So the initial side, when it overlaps with the terminal side, the amount of turn is the angle. Positive angles are measured counterclockwise, and negative angles are measured clockwise. So if you go clockwise ever, it will be negative. Two angles with the same initial and final side but different measurements are called coterminal angles. So, for example, if I rotate 360 degrees, the 0 is coterminal to 360 because 360 degree rotation is the same thing as a 0 degree rotation. It lands you in the exact same spot. 60 degrees is coterminal with minus 300 because if you take 60, that's like this spin, minus 300 a clockwise spin. Boom, you get the exact same place. And it's also coterminal to 420 because we have 60 and then we have another 360 degree turn. Boom, you get to the exact same space as the 60. So if you want to find the coterminal angles to whatever angle you're given, always just add 360 degrees or subtract 360 degrees or 2 pi radians to the angle. 2 pi radians also work. It doesn't have to be only 360 degrees. Because 2 pi radians is 360 degrees anyways. So what we can do is we can use our knowledge of trigonometric functions to implant it in a circle. And the reason why the circle is so good is because every single radius of the circle we get is the same length for every height of the hypotenuse. So we have we can set this right angle triangle to sine theta, which is y over r, opposite over hypotenuse, opposite y coordinate over hypotenuse r coordinate, the radius of the circle, which is CSC is r over y, cosine is x over r, right, and secant is r over x, opposite, right, tangent is y over x, because opposite over adjacent, right, and cotangent is x over y. And it works everywhere. It works here, it works here, it works here. Okay? And we're gonna depend on this a lot, right? So we have question 3 from 4.3 right now. Question 3 from 4.3 says, evaluate the 6 trigonometric functions. Um, we're not going to evaluate all 6 trigonometric functions. We're going to do sine, cosine, and tangent because the other 3 are kind of waste of time. So we do this, and then we do -1, 2, -1, 2. What are the coordinates of this? Okay, I forgot to mention. The coordinates of this determine whether it's a sine or a cosine. That sounds a little weird. The coordinates of this determine whether it's negative or positive for the sine or cosine value. So if it's -1/2, we can construct a triangle like this, where the length is 1 and 2, right? The length is 1 and 2. So if we want to find the sine of this, the sine is just going to be opposite over hypotenuse. What's the hypotenuse? 1 squared plus 2 squared is 5, and square root of 5 is the hypotenuse. So our circle radius is square root of 5. Sine of this theta angle, the theta angle always goes from the center. So that's the theta angle, right? The theta angle always is in the center. So the sine is 2 over square root of 5. Right? It's just 2 over square root of 5. It's 2 over the square root of 5. Is it positive or negative? Well, we already determined that the sine is y over r. It's y over r. So the y value isn't negative, neither is the radius. The radius can't ever be negative. So since the y value isn't negative and the radius isn't negative, it's positive. How about cosine? Cosine is adjacent over hypotenuse, 1 over square root of 5. But is cosine negative? Well, cosine is negative. Why is cosine negative? Because the x coordinate was negative. It's -1, 2. So it's -1, square root of 5. And tangent, if we do tangent, I actually derived this identity right here. I didn't talk about it enough. But tangent, you can see, is just y over r over x over r. Because it's opposite over adjacent. And it's equal to y over x. So you can put both of them over r, and then you can derive that tangent theta is equal to sine over cosine. So tangent is sine over cosine. Sine over cosine is 2 over -1, which is equal to -2. Or you could just see that sine positive, cosine's negative, it's 2 over 1, and so since sine is positive and cosine's negative, it will be negative, -2. Question 12. Let's see about question 12. Question 12 this time, the circle, is on 22 minus 22. 22 minus 22. That's about right here, right? This is the circle. This is the triangle. And you could see that the y is negative. So since the y is negative, we automatically know the sign is going to be negative. And since the x is positive, we automatically know that the cosine is going to be positive. So the tangent is automatically going to be negative because negative divided by positive is a negative. But which one is it? So we have 22 and minus 22. 22 and 22. So that's 22, that's 22. It's a freebie. It's basically a freebie for us. Because that's 22, that's 22, that's 90 degrees. It's an isosceles triangle. So this is 45, and this is 45. And what did I say about 45, 90, 45 triangle? You could use the song, or you could use a special right triangle. I'm going to use the song, right? 1, 2, 2, square root of 2 over 2. 3, 3, 2, square root of 2 over 2 again, right? But because it goes 30, 45, 60. 2 under, everybody. Square root, where has no 1? Square root of 3 over 3. 1. Boom, 1. Got it. That's all. That's everything, right? The song helps. The song really helps. But the fact that you just can derive also really helps, because this is 22. This is 22. This is just gonna be square root of 22. No, this is just gonna be 22 square root of 22, and you can just no, not 22 square root of 22. 22 square root of 2. And then you can just do the sine, cosine, tangent really easily, right? So determine the sine of this without using a calculator. Only the sine, right? So we see on cosine of we see on tangent of 125. It's in here. It's in around. Okay, I'm gonna draw a big circle. Tangent of 125 is around here, right? It's around here, and the tangent of 125 around here is the cosine is negative, and the sine is positive. So automatically it's negative. Cosine of 216. Where's 216? 216 is around here, right? This is 180. This is 90. 216 is around here. The cosine, the x value is negative, so it's negative. Right? I didn't even know why I put an extra equal. Sec of 89. Sec is 1 over cosine. So what's the cosine? It's around here, and even though it's really close to 90, it's still positive. So it's positive. So sec is going to be positive. 13. This is a reference triangle. Okay, I've told you about reference triangles already, pretty much. Reference triangles are literally just making triangles that exert from the center, right? There's a radius and then there's a y and x, right? That's what a reference triangle is. So when it's reference triangle minus 5 pi over 6, it's just you have to find a coterminal angle to work with it. So sine of minus 5 pi over 6 is just sine of 7 pi over 6 because you add 2 pi. And then at the end, you'll get something like this, which is this reference triangle right here. And then this is just going to be 30 degrees. And then you'll just work it the exact same way. It's minus because it's then y coordinate is negative, right? So it'll just work the exact same way. And I'll actually delete these triangles because they're disgusting. So what's tan of 7 pi over 3? Tan of 7 pi over 3 is, if you use the coterminal angles, this is actually too big. This is bigger than 2 pi. So if you want to actually make it smaller, you have to subtract by 2 pi. If you keep adding 2 pi, it'll be 13 pi over 3. It'll become unmanageable. So you subtract 2 pi, and you'll get tan of pi over 3. And what's tan of pi over 3? Pi over 3 is 60. It's tan of 60. So you can just sing the song, right? 1, 2, 3, 3, 2, 1, 2 under everybody. Square root of 3 over 3, 1 square root of 3. Square root of 3. It's square root of 3. That's it. Or you can do the obviously triangle stuff. It's totally fine as well if you do the triangle at 60 degrees, right? It's totally fine, but the song is probably the better bit for 30, 45, and 60. Question 43 and 46, 2.3. How about, no, we're not gonna do this. We're gonna do this next time. I need to put a note to do this next time. Question 43, 46, 2.3. It's just more analysis. So what's the unit circle? What I've been talking a bunch of junk about everything, but I haven't talked about something called the unit circle yet. The unit circle is the circle with radius of 1. Why is the circle with radius of 1 so useful? Because we can then generalize. Right? Sine theta is y over r. We already all know that. But if our r is 1, then sine theta is just the y coordinate. It's just going to be the y coordinate, which I already told you. It's the y coordinate. I already kind of suggested you that it's the y, and cosine was the x. Right? So sine is the y, and cosine is the x, and tan is y over x, as I've already told you. But how are we going to make the song work this time? How are we going to make the song work if we have our 30, 45, and 60, but we have all these other angles? Well, the song is going to work by counting from this part, from here. So if it's 30, 45, and 60, you count from here. If it's 120, 135, and 150, you count from the 150 first. Right, 150 gets counted first. If it's 210, 225, 240, 210 gets counted. 330 gets counted. Right, so you have to count from the x-axis. So if it's let's say, okay, I have tan 240 right here, but let's say it's cosine 315. Cosine 315, right? So you see that it's 270, and you see this is 360. So it's 330, then 315, then 300. This might seem like a lot of work, and honestly, the better way to do it probably is just to do a triangle. But if you really want to get this song, if you really want to like have this song into your head, you could just try it again, right? So it'll be cosine 45, cosine 315, which is a 45-degree angle in this counting system. It'll be 1, 2, 3, 3, 2. There you go. You got it, right? 1, 2, 3, 3, 2. Square root of 2 over 2. Done. And that's if you know that 315 is in between 0 to 270. Some people might not have that in their head automatically, and might take quite a while to figure that out. So that's all. That's all fine and dandy. This is just a little bit of terminology as well. So we have as our sine function rotates around this circle right here, as the sine function rotates, this is the graph that it's making with respect to time. Let's say if it's rotating 1 radian per second, this is the graph that it's making with respect to time, and we'll go back to this. This is the y-axis, right? And as the cosine function rotates, I flip this graph a little bit. This is the graph that it's making. See, as you can see, the orange bit corresponds to the orange bit. The blue bit corresponds with the blue bit. The blue bit corresponds with the blue bit. Orange, orange, green, and it keeps going, right? Because coterminal angles, right? So the time it takes for the wave to go through one cycle, right? This is a wave, and the time it takes for you to go one cycle is called a period, and it's 2 pi. So which one is sine x and which one's cosine x? Well, let's see. That's x, so cosine x. No, that's x, so cosine x. And that's y, so sine x. Pretty obvious. So find sine of pi over 3. Find sine of pi over 3 plus 6,703 pi. This is gonna seem a little bit ridiculous of me to put 6,703 pi, but remember, it's a period, and one period is 2 pi. So after one period, it's one cycle. It'll go through the exact same cycle over and over and over again. So 6,702 out of the 6,703 is useless. It doesn't give you anything. So it's, in reality, it's just pi over 3 plus pi, which is 4 pi over 3, which is 240, if you want to work in degrees, but I'm going to work in radians. So 4 pi over 3 is like right here in the triangle. You can sing the song, or you can just work it out, right? I'm going to sing the song. So 1, 2, 3, square root of 3 over 2, and it's 4 pi over 3. It's in this part of the circle, so it's negative. Negative square root of 3 over 2. 1, 2, 3. So our properties, we have our cosine now. So minus cosine of this and this. This follows our cycle, and this follows our cycle. They're both one cycle. So after one cycle of the cosine function, you could see the cosine starts as 1. It starts at 1. So after one cycle of the cosine function, it goes back to 1. So this is just a multiple of the cycle, and this is a multiple of the cycle. Therefore, this is 0, and this is 0. So cosine of 0 over 0 is 0, cosine of 0 is 1, and minus 1 is the answer. Right? Because that's 0, and then cosine of 0 is 1. So this is some of our properties. I think you already figured some of these out, but this is one of the most important properties right here. Cosine squared theta plus sine squared theta is 1, because x squared plus y squared is r squared. And when r is 1, x squared plus y squared is 1, and we have our cosine, and we can put our cosine and our sine in to get you this identity. It's a Pythagorean identity, right? And the Pythagorean identity is x squared. The Pythagorean theorem is x squared plus y squared a squared, b squared, c squared, but this is the identity of Pythagoras. Even though he didn't actually come up with it. So by using some of these formulas, if sine theta is 3 over 7 and theta is between pi over 2 and 3 pi over 2, what's cosine? So we have our sine, right? Use this formula, 3 over 7, so cosine squared theta plus 3 over 7 squared is equal to 1. That's 9 over 49 equal to 1. Cosine squared theta. So that will be cosine squared theta is equal to 40 over 49. So cosine theta is equal to square root of 40 over 7. And is it negative? It's between pi over 2 to 3 pi over 2. Pi over 2 is 90 degrees, 3 pi over 2, 270 degrees. Take the look at the circle, 90 degrees is on top, 270 degrees on the bottom. And it's all on the x-axis. So if you move past 90 degrees, it's going to be on the negative x-axis. Therefore, it's negative. Minus square root of 40 over 7. Two final questions. Question 55. This review is still taking an hour. I don't know why my reviews take so long. I significantly lowered the number of questions on this review. Question 55 for 2.3. It's just it's a bend light question. So imagine this light is bent through a mirror like this, right? Refracted through a mirror. That's the technical term. And this is theta 1 and this is theta 2. It's called Snell's law. So, wait, no. That this is not theta 1 and this is not theta. Okay, we'll put a line that it. This is theta 1 and this is theta 2. No. This is theta 2. So this the formula is sine of theta 1 equal r sine of theta 2, or mu. I'm gonna put the mu in actually. Mu sine of theta 2. Mu is a Greek character and also an idol band. Anyways, sine theta 1, right here we have our sine theta 1 is 83. Sine 83 equals mu sine 36. So mu is just going to be equal to sine 83 over sine 36. And that's it. That's literally the question. Question 73 and 74. Okay, so we have this circle right here. I'm pretty sure you've done your transformations in the 8th grade. But whenever you rotate something by 90 degrees, what happens to the coordinates? It goes x comma y. You rotate it 90 degrees, you get this, right? This is a 90-degree rotation. This is x comma y. We have our y, we have our x. This looks like the y now, and this looks like the x now. Could you see? This looks like the y, and this now looks like the x. So this is x comma negative y. Not x comma negative y. This negative y comma x. So now it becomes negative y comma x whenever you rotate it 90 degrees. So let's try to visualize that, right? Using sines and cosines. So we have sine theta, cosine theta. No, that's wrong. I'm sorry. Cosine theta, sine theta. If we add 90 degrees, so rotate 90 degrees counterclockwise. So rotate 90 degrees, which is also pi over 2. So cosine pi, this is going to be, you'll get cosine of theta plus pi over 2 and sine of theta plus pi over 2. But what will you also get? What will you also get? You will also get minus y over x. What's minus y? That's minus sine theta. And what's x? Cosine theta. Right? So this, we've just established that this is equivalent to this, and this is equivalent to this. And that's 73 and 74 slashed in one question. Right? Sine theta plus pi over 2 is cosine theta, and cosine theta plus pi over 2 is minus sine theta. and this is the reason why, right? If you move this here, if you move this triangle to right here, you'll get this is xy and this is minus y. That's it. Over. The review is done. So the review is probably gonna last about 70 minutes. I'll probably like speed myself up by 1.1 time. Just from Movie Maker, just from Movie Maker alone, I'm gonna speed myself up by like 1.05 times. If you guys want to speed me up more, you guys are welcome to. And I'm going to put timestamps on this because I have a lot of time to do so. So I'll see you next time for the 2.4 to 4.4 to 4.8 review.